Hi everyone and welcome to my YouTube channel. So we're continuing our inequalities playlist, and in the last video we discussed our starting examples of the AMGM inequality. We discussed many ideas including the pairing technique. We also discussed how to apply AMGM in reverse, and we basically solved our starting examples on the AMGM. So in this video we'll be continuing with that, but we will be, of course, discovering new ideas of the AMGM, because as I told you, if you want to master inequalities, then you have to master the AMGM first. So what are we waiting for? Let's get started. Alright, so our first example is the following. So we need to find the maximum value of the following expression: x times 1 minus x cubed. Of course, they're telling us that x is between 0 and 1. Alright. Let's see how we can deal with this question. So first of all, if you can see, this question is a bit strange regarding, like in comparison to the previous problems, since here we're asked to find the maximum value. This is not basically telling us prove that something is bigger than something or smaller than something. Here actually we just have one term. So if you can imagine you have an inequality here, then we just know that we know the LHS. Here our job is to find the RHS, to figure out what is this. For example, it might be 1 or 2 or 3, and then to prove the inequality. So here actually we need to do two tasks. We need to find out what is this number, and we need to show the inequality. Of course, sometimes it's really doesn't matter. Sometimes you just apply inequalities here a bit by a bit until you get a number here. Okay. Of course, we have some condition here that x is not anything. It's between 0 and 1. We need to keep that in mind. And the second thing that we can notice is that we only have one variable, which is x, unlike our previous examples where we had x, y, and z, or a, b, and c. Okay, so let's see how we can deal with such a question. So first of all, of course, we need to apply some inequalities to maximize this, so something like this. All right, so actually these types of questions, you have two ideas to apply here. The first idea, if you know some calculus, then simply this is perfect for you, because you will just take some derivative and stuff, and you'll just be able to solve such questions. Like, it's very easy to solve these questions. Like, you just define a function f, and then you study the function f on this interval, and you can easily find the maximum value. If you don't know calculus, then I recommend that you do, because it's really important. Although it's not mandatory in Olympiad to know calculus, it's really recommended that you know some calculus, because lots of inequalities where you need to apply, for example, Jensen or other cool inequalities that can make your life easy, you really need to know some calculus. Okay, so right now we will not be discussing the calculus method. If you know how to do it, then please post it in the comments below. Here we'll be discussing the other solution, which is simply to use the AMGM. So how can we use the AMGM here to find the maximum value of this expression? Well, remember, the AMGM, if we want to make it like something is less than something, we want to maximize it, then we need to have a pi, right? Pi is less than sigma. Do we have a pi here? Well, yes, we have. This is times this, so this is perfect for us for the AMGM. Okay, so how can we apply AMGM? Like, if we just apply it like this one number and this is the second number, it will be garbage, useless, because we will have something like this: 1 plus x minus x cubed, of course, like some roots or something squared. But the main point is that this is useless. We did not cancel. Remember, our goal is to get a number, to get something like 1 or 2, a number. We want to get rid of the x totally. So this does not do this job, so it's useless. So although we have a product, this here we have x to the 1 and here x cubed. We need to figure out a trick to make them the same. For example, if we can make this x, then it will be perfect. Or if we can make this x cubed, it will also be perfect. So how exactly can we make x cubed? Because clearly making this x is kind of illogical. So how can we make this x cubed? Maybe like you might think, okay, if I multiply by x squared and divide by x squared, like I will have something like this, and here cube. I can apply the AMGM, but guess what? Okay, you did it here, but still you have x squared here. So this is not good idea. So instead, what can we do is, and this is really important idea, keep it in mind. We can simply, if you want to have a cube, then just cube the whole inequality. So if we just cube the whole expression, and of course you need to keep that in mind, because if we get now a new value, then we need to take the cubic root. So if we call this, let's call it t, then what is t cubed? It's x cubed times 1 minus x cubed cube. Okay, that's cool. We have the x cube here. But now you know what's the problem? We have also a cube here. So now we have cube here. So how can, what's the benefit? Well, the idea is actually pretty simple. You have cube here. You can think about it as a product of 3 numbers. So you can say it's like this: x cubed times 1 minus x cubed, 1 minus x cubed, 1 minus x cubed. So now, if we apply the AMGM, here we have an x cubed. Okay, it will cancel one of these, but this is a problem because we still have minus 2x cubed here. So what can we do? Well, another trick. If you were able to find this trick, then for sure you should be able to find a trick that handle this as well. And this trick is really simple. Okay, so we want 3 of these, right? No worries, just put a 3 here. Remember, here we're working with inequalities, so we need to always have these tricks in your mind. So we can simply say 3 t cubed is equal to 3 x cubed and this stuff. So now actually you can just apply the AMGM, and now everything will be really cool. So of course we'll apply AMGM on 4 numbers: 1, 2, 3, 4. So basically, let's do that. We'll have 3x cubed plus this plus this plus this. So the x cubed will cancel, and we'll just have 3 here. 3. But of course, you need to be careful. If we're applying it on 4 numbers, it's like what version we're applying: a plus b plus c plus d over 4. We know this is greater than the fourth root of a, b, c, d. So if we want to get rid of that, we need to raise this to the power 4. So here we have a, b, c, d, and we want the sum. So we need to divide that by 4. So 3 over 4, and to take all of that to the power 4. So now it will be 3 over 4, all to power 4. All right. Okay, so that's cool. We found the maximum value for t. And of course, now you just need to do that. That means 3t cubed is less than 3 to the 4 over 4 cubed. We can cancel a 3 with a 3 and take the root. Then it will be 3 over, oops, here I think it was 4. It's 4. It's just like this. Actually, we can make like this. And this is basically the maximum value for t. All right. So we got the maximum value for t. But is that enough? No. Always you need to be careful. When you have when you're asked to find the maximum value and you just showed that, okay, t is less than some number, maybe 4, maybe like whatever, then this is not enough. Because they are telling you find the maximum value, they're not telling you just give some upper bound. Like t should be equal to 4 for some values. So we need to make sure that the equality can hold by simply just giving an example. And of course, how can we figure out when does the equality hold? This is easy. Just look here. So where did we apply the inequality? Here, right? The AMGM. When does the AMGM have equality case? Of course, when all the numbers are equal. Of course, these are already equal. So we just need to make this equality. So let's say you're just discovering the equality case. You can simply just say 3x cubed is equal to 1 minus x cubed. That just means that x cubed is equal to 1 over 4. So that just means x is equal to 1 over cubic root of 4. So you can simply here just say with equality when x is equal to 1 over cubic root of 4. Of course, you can check that by just putting x, but okay, this is for sure. All right, so that's it. We're done. So what's the point of this question? AMGM can be used to find maximum values or minimum values. Of course, you can solve it using, as we said, calculus, but you can apply also AMGM, but you need most of the times to do some tricks. For example, here we just thought about it logically. How can we get rid of the x and x cube? We just thought this idea, taking a cube and then inserting a 3 here, and then we were just done. And of course, never forget the equality case, because this is find a maximum, or even the like minimum. It's also the same. By the way, here also we did not pay attention to something. We need to make sure that x is between 0 and 1 in our equality case. Let's check here. Okay, x, this is the value for x. Is this between 0 and 1? Well, obviously yes. Another thing, we apply the AMGM here, right? So we should actually be careful, because remember, the AMGM, we need the numbers to be positive. We need to make sure that we have this. And here, yes, indeed, they are positive from the condition they told us. Okay, so everything is good. And okay, that's it. All right, so now we move on to the next example. So in this question, we're given that A, B, C are all positive numbers, and they're telling us that 1 plus A times 1 plus B times 1 plus C is equal to 8. And they're asking us to prove ABC is less than 1, less than or equal to 1. All right, how can we do that? Well, we simply here have a condition and like immediate inequality, direct one. So try to think about this question, because you should be able to solve it easily. Okay, so what's the idea here? Look, here we have some equality. 1 plus A times 1 plus B times 1 plus C is equal to 8. And we need to show that ABC is less than something. And by the way, you should always know that ABC is really a small thing, small quantity, so it's always less than anything. For example, like if you think about AMGM, then most of the times you'll get ABC on the lower side, right? Of course, like you might have something like this, but it's always on the lower hand side. Okay, so that's a good thing. It's less than something, so that's logical. Okay, anyway, how can we deal with this? Okay, this actually idea we have covered multiple of times. Basically, take a look here. You have 1 plus A. You can apply the AMGM like this, right? You can say 1 plus A is greater than 2 root A. Same thing, 1 plus B and 1 plus C. So you can simply say that the pi of 1 plus A, which is equal to 8, is greater than or equal to the pi of 2 root A, which is just 2 root ABC. So basically we're done. That just means that ABC is less than 1, because this is less than 8. Okay, so as you can see, this is the same idea. But actually, I brought this example to discuss something else. Like we'll basically discuss another idea here. Of course, this is the ultimate solution, like the best solution, but I just wanted to clarify something, which is what happens if we just expand this. Let's do that. So let's say this is kind of solution 1 and also solution 2. So let's expand this. Of course, we will get 1, we'll get sigma A, we'll get sigma AB, and ABC. By the way, it's really important that you can expand really quickly, and you can just think about this logically. We have 8 terms, 2 to the 3, so these are 8 terms, 1 term, 1 term, 3, and 3. Okay, so we expanded that. We know this is equal to 8, so that basically means that we know sigma A plus sigma AB plus ABC is equal to 7. Okay, so guess what? They're telling us, show that this thing here is less than 1. Well, guess what? Let's assume it's greater than 1. What will happen? So assume ABC is greater than 1. Then this thing is greater than 1, right? Okay, what about this and this? Remember that the AMGM tells you that ABC is the smallest thing ever. So that means sigma A is greater than that, sigma AB is greater than that. So if we just apply the AMGM, we know that sigma A is greater than 3 cubic root of ABC, which is 3, because ABC is bigger than 1. Same thing, sigma AB is greater than cubic root of ABC, but here they are squared, which is also 3. Oh, sorry, it's not equal, it's greater than. Okay, so that means sigma A is greater than 3, sigma AB is greater than 3, ABC is greater than 1, so their sum is greater than 7, a contradiction. So our assumption here was wrong, hence ABC is less than 1. So that just gives us a contradiction. Since sigma A plus sigma AB plus ABC is equal to 7. And hence, of course, ABC is less than or equal to 1. Okay, what's the idea of this solution? The idea is always know that ABC is the smallest number. So in lots of questions, they might ask you and give you some condition that maybe like they are telling you solve some question, and they gave you ABC is equal to 1. Then you should immediately in your mind establish these 3 things in your mind. This is an immediate direct thing that should be in your mind. Okay, this is if ABC is 1, then you already know sigma A is bigger than 3, sigma AB is bigger than 3, sigma A squared is bigger than 3. If they told you it's greater than or equal to 1, then the same thing, you can also do the same thing. If they told you it's less than 1, then you can't know anything, because okay, that means just ABC has an upper bound, so that doesn't mean anything. Okay, similarly, if they told you sigma A is equal to 3, what does that mean? That means, okay, we know like something about sigma A. That means we know that ABC is what? It's less than 1, right? Think about it just by AMGM. Also, that means that sigma A squared is greater than what? Can you like have a bound on sigma A squared and sigma AB? Think about it. Okay, so I will tell you what exactly is it. But sigma A squared is actually greater than sigma A all squared here times 3. You can easily see why this is true by just expanding and remembering that we already know that sigma A squared is greater than sigma AB. So just keeping this in mind, this gives you gives you all the inequalities that you will need. If you know sigma A squared is greater than sigma AB, then it gives you this, and that means we know that it's greater than 3, because this is 3, so 9 and 3 cancel, so it's 3. What about sigma AB? Well, guess what? The same idea. You can actually prove that this is equal, like a greater than 3 sigma AB. So I really want this inequality to be always in your mind. because it's really important, because that also gives us sigma AB is less than 3. And so on. So for example, let's say also they told you sigma AB is equal to 3. Then what can you know? Should like figure it out. So first of all, ABC, you know it's less than 1. Sigma A here, you know it's greater than 3. And sigma A squared, you know also is greater than 3 by just applying these again. Okay, of course, that also means if they told you sigma A squared is equal to 3, then everything else is less than, because sigma A squared is a beast. So sigma A is less than 3. Sigma AB is less than 3 as well. So it's really, really important to keep this inequality in your mind. It's really simple, just AMGM. By just like expanding, you will get sigma A squared is greater than sigma AB. But it's really powerful because you will see this a lot and a lot in inequality problems. They might give you this, might give you this, this, or this. You should always immediately derive these inequalities. Don't like say, okay, you found this example, but then you got stuck here. Come on. Always know that these things are always true. Okay, so with that discussion aside, okay, let's now move on to our final example for today. So, problem 3. All right, this question is from the USAMO 2011, problem 1. Okay, so now we're given 3 positive numbers, and they're telling us some condition, which is a squared plus b squared plus c squared plus a plus b plus c squared is less than or equal to 4. And they're asking us to prove. Of course, I will not write it all, because as I told you, it's much simpler just to use the sigma notation. Sigma AB plus 1 over a plus b squared is greater than or equal to 3. Alright, so of course that just means AB plus 1 over a plus b squared, then BC plus 1 over b plus c squared, and then CA plus 1 over c plus a squared. The sum is greater than 3. Okay, so how can we deal with such question? So here we have a condition and an equality that we need to prove. So how can we deal with that? Okay, first of all, if we just look at the condition they gave us, clearly we can do some stuff to this. We should not just be looking at it like this: a squared plus b squared plus c squared plus a plus b plus c squared. So like the simplest idea is just try to expand this and see what can we do after simplification. So of course, if you just expand this, you will get sigma a squared, which is the same as this, plus 2 sigma ab. So you will have 2 sigma a squared plus 2 sigma ab is less than 4, and we can thus cancel the 2. So basically the condition tells us the following. So we know that actually sigma a squared plus sigma ab is less than 2. This is basically the condition. Okay, and now we need to prove this inequality. How exactly can this, it's like really too big, how can it help us here in this inequality? It's kind of seems not related. How can we go from here to here? Okay, so if we think about this question, then we will here need some actually idea that we haven't explained yet, which is the idea of homogenization. This idea is really important, and also you will need it a lot in your inequalities journey. So let's explain that. First of all, what does homogenization mean? What is a homogeneous thing, or like a function maybe? So let's say we have some polynomial, okay? Some polynomial with more than one variable. So let's say 2 variables. Let's say this x to the 4 plus 3y to the 4 minus 2x square y square. Okay, if you look at this polynomial with 2 variables, then you can see that what is the degree of this thing here? The degree here is 4. What's the degree of this term? It's also 4. What's the degree of this term? Remember that a degree is always the sum of the powers of the variables. So here it's 2 plus 2, so it's 4. So as you can see, all the degrees of each term, all of them are equal. So we call this P, we call it homogeneous. So P is homogeneous. All right, because each term has the same degree. You can think about it also like this. If we introduce some variable k, then pkx, pky is equal to k times pxy. So basically the k will get absorbed outside. So here if you put a k, k to the 4, k to the 4, k to the 4, so the k will be outside. Of course, like here, I don't really mean it's basically the k, but just the k will get absorbed. So for example, here it will be actually to the 4. Okay, but just this is the idea, that the k will be outside, and you will have the pxy, just the pxy, the same pxy. Okay, so in general, this idea is either like you look at the terms and the degrees, or you can just think about this thing. If the k got absorbed outside, then this is also homogeneous, same idea. So what does this have to do with our inequalities? Well, let's say you're solving some question, and like maybe you have two functions. Of course, not necessarily polynomials, but you can do the same idea here. And maybe like they're telling you prove that f is greater than g or something. And of course, maybe here a, b, c, and also here a, b, c. So guess what? The same idea can be applied. If f is homogeneous and g is homogeneous, then that means the k here will get like here. And also, if we just put ka, kb, kc, and here ka, kb, kc, then the k will be outside, and the k will be outside. And if you were able to cancel the both k's, so exactly, for example, here we got k to the 4 and here k to the 4. If we can cancel them, then this is also a homogeneous thing. Of course, you can also look at the degrees again. Okay, let's take an example, because maybe like this explanation is not the best. So for example, let's say we need to show that a square plus b square is greater than or equal to 2ab. So is this homogeneous inequality? This is, by the way, the AMGM for two variables. So let's see. Here, what's the degree? 2. What's the degree? 2. What's the degree? 2. So indeed, this is homogeneous. As you can see, all the degrees are the same. Also, you can think about it. What happens if I put ka, kb? What will happen? Well, here I will have k squared, k squared, k squared. So the k squared will cancel. So it's actually the same as a and b. So this is a homogeneous inequality. Actually, the AMGM itself is homogeneous if you think about this. If you replace all the numbers with ka1, ka2, and so on, kan, the k will cancel. K to the n, all of these, and k to the n from these. So we'll also get it's the same as a1, a2, till an. All right, perfect. So it's homogeneous. The AMGM is homogeneous indeed. Of course, you can also think about degrees here, degree n for each term, and here also degree n. So same thing holds. All right, so these homogeneous inequalities are really nice. And what's the idea? Okay, why are we talking about that here? What's the idea of like condition and the inequality? First of all, let's take a look at our inequality here. Is it homogeneous? Let's see. So the degree of this thing here is 2. Wait a minute, the degree here of this thing is actually 0. So this is kind of like from here we can see that it's not homogeneous, because if it was to be homogeneous, first of all, let's analyze all the degrees. This is degree 2, this is degree 0, here the denominator is degree 2, and here is the degree 0. So if we want this to be homogeneous, we just need to have this instead of 0, 2. Then we'll have 2 and 2, and here 2, so they will be like the degree of all this thing, it will be 0, and here is 0, so everything is cool. So now if we put k, ka, kb, kc, we will have k squared from here, k squared from here, k squared from here, and here, okay, they will cancel, and here we don't have any k, so that's good. However, that's not the case here. Here we actually have, this is 0. So if we will get a k square here, like here we have 1. So we can't cancel the k. So as you can see, that means our inequality is not homogeneous. All right, what's the idea? The idea is to make it homogeneous. How exactly? We're going to use the condition to force the homogenization of this. And this idea is really, really important. Why? Because once you homogenize your inequality, then you can just totally forget about the condition. Of course, that will be perfect, right? Imagine if we can find a way to just forget about the condition, and this is by force. It's not like using some creative ideas or like anything. So we'll just force this inequality to be homogeneous. This is our plan, and then that means we will get rid of the whole condition. How can we force this homogenization? Well, this is not difficult at all. Remember, our whole problem is with this one. If we can replace this one with something of degree 2, then we're done. How can we force that? Well, look at the condition. We know that 2 is greater than something, and this something is homogeneous, and it's degree 2. So what is 1? Well, actually, one just trick, you can multiply everything by 2 here, and replace this one by 2, and then just apply the same inequality here. All right, so let's do that. Of course, you can also like do here, a 1 here, and put this 2. But okay, let's just do that. Easier, like to get rid of the fractions. So let's multiply everything by 2, and then use this idea. So let's try that again. So here, we need to show that sigma now 2ab, because we multiplied by 2, plus 2 over a plus b squared. And of course, now we multiply by 2 as well, so it's 6. So now remember that the LHS is now greater than sigma 2ab, I will keep it, but 2 I will replace it with sigma a squared plus sigma ab over a plus b squared. And of course, our goal is to show that this is greater than or equal to 6. Okay, so now this is homogeneous, as we said. Now this is degree 0, and we need to show that it's greater than 6, which is also degree 0. So now we have a homogeneous inequality, and now guess what? We can totally forget about the condition. Okay, that's perfect. So let's just focus on proving this, just like any other problem. Okay, of course, you need to do some algebra here. Clearly, you can cancel some stuff. So here you have a plus b squared. Here you have 2ab. So you can take an a squared from here plus b squared and cancel that. So we'll get 1 outside. Actually, 3 ones. So we'll actually have this. This is the same as 3 here. And here, what do we have now? Sigma. We have c squared, and we have plus sigma ab, right? Over a plus b squared. So now we just need to show this inequality. All right, how can we deal with this inequality? Actually, this one here, it's really important that you notice this. Whenever you see something like this, there is a formula for that. Actually, you might say that in algebra, we have some formula, right? For example, we know a plus b squared is a squared plus b squared plus 2ab. Same thing for difference of 2 squares, a squared minus b squared. Same thing for a cubed plus b cubed. And a plus b cubed, all cubed, and all of these formulae. However, there are some special formulae that you need to know if you want to study inequalities, and this is one of them. So you should know when you can factorize stuff. For example, this is very important formula that you need to keep in mind. A squared plus sigma ab. Okay, let me write it as this: ab plus bc plus ca, or just a squared plus sigma ab. This thing, you should know that you can write it as a plus b times a plus c. All right, so this formula is really important. Actually, I'm going to write some other formulae that are really important as well. One of them is the following. Basically, you need to know that sigma a square. Oh, sorry. Sigma a square b symmetric plus 2abc. Also, you can factorize this. In fact, it is what? It is just pi a plus b. So it's just a plus b times b plus c times c plus a. Also, you should know that sigma symmetric a square b plus guess what? It's the same thing, ABC, however, it's 3. You really need to be careful not to mix between these. You can also factorize this, and it's actually sigma A times sigma AB. Of course, what's the proof? You can just go from the right hand side to the left hand side. Just expand this and you will get this. Expand this and you will get this. So these are really some important formulae that you need to keep in mind, as if you don't notice them in the question, you're doomed. You will never be able to solve the question unless you are able somehow to factorize this. However, like if you're really experienced, then you will, once you see this, you'll say, wait a minute, I can just replace it with C plus B times C plus A. Okay, so let's just apply that here. So now that means the LHS is equal to sigma C plus A times C plus B over A plus B squared. And of course, our goal is to show this. And actually now it's really obvious. You should be able to find that from here. This is just the AMGM, right? These numbers are repeating here and in the second fraction and the third fraction. So if you just apply the AMGM, then it's correct. So in fact, this is just from the AMGM on the 3 numbers. They will cancel, as we said. The numerators, the 3 numerators with the 3 denominators. All right, so that was the this USAMO problem. So actually, this question was not difficult at all. The idea was like really direct. You have an inequality and you have a condition. Okay, first of all, this condition is just this. So let's basically get rid of the condition by just homogenizing the inequality. How can we homogenize it? We can force the homogenization by just like putting the 2, replacing the 2 here with this thing here. Sometimes the homogenization is really clear. Sometimes it's more tricky, but it's always kind of possible. Okay. Sometimes, however, stuff might get ugly. So it's not a rule of thumb whenever you have a condition, then just homogenize the inequality and get rid of it. Sometimes the inequality might really get ugly. However, it's really a good idea to always keep that in mind and try it if like possible. So here, okay, we just homogenized, and then our inequality was like this. Then, of course, just some algebra like this, and then we notice the factorization. Once we wrote the factorization, then it's just AMGM, and we're done. By the way, it's really important that whatever I tell you, like during the lesson, that really you need to memorize. For example, if I give you this, then you need to memorize. Like once we see another problem, then I will not, like I would have expected you, like during the course, if you have watched the first videos gradually, that you already know what are these. Okay, so really make sure that you memorize these things, because they're really important and they will bump up again and again. All right, so actually that's it for today. We're still not done with the AMGM. We will, I think, just have one additional lesson, and we'll be wrapping up the AMGM tricks. So that's it for this lesson. All right, so in this lesson, we discovered, or we solved 3 examples on the AMGM. The first example showed us the power of the AMGM in finding maximum, minimum values, even when you have just one variable. You can just apply the AMGM, but you need to have some tricks, to do some tricks. You can always think about the AMGM and say, how can I get rid of the variables? So here the idea was simply to cube it and then just multiply by 3. And of course, we were done. We also really emphasized on this when in the questions that ask you about maximum or minimum, you need to show the equality case. Like the equality case needs to hold. Otherwise, it will not be a maximum value. It will be just some upper bound, but it's not a maximum value. Then, in the second example, okay, this was an easy question, but the idea that we wanted to stress on was this. When you know ABC is 1, then you already have 3 inequalities on sigma A, sigma AB, and sigma A squared. By the way, you have other stuff as well. For example, sigma A cube is also greater than 3. But these are really, will appear a lot in nearly, in most of the, maybe like 80% of the inequalities, you will see ABC or sigma A or sigma AB or sigma A squared. So that's why we just discussed these. Also, if you know sigma A, then you can use this inequality. That's really important. With like force, it's really direct proof from the AMGM that you really need to keep in mind, because it also helps you to know or to relate sigma A squared to sigma A all squared and to sigma AB. So once you know any of these, then you already know some inequalities, upper bounds, lower bounds on the the others. And finally, we finished with the cool USAMO problem, which illustrated the idea of homogenization, which is really powerful. The idea is simple. They give you a question. You have a condition and an inequality you need to prove. You just homogenize the inequality using the condition, and then you can totally forget about the condition, and then you just need to solve or to prove a homogenized inequality using just the ordinary tools that you know. For example, AMGM right now, our only tool. But later on, of course, we will have other tools as well. The same idea will repeat. In fact, we will discuss a whole lesson about homogenization and other ideas, but this was just to let you know, because we will need these in all the other lessons as well, this idea. And finally, always you need some formula. Whenever you get some nice formula, so solving some question, some factorization formula, then always you need to memorize them in inequalities. They will really help you a lot. Okay, so that was it, my friends, for today. I hope you enjoyed this video. Please like, share, and subscribe to my channel, and see you guys in the next video.